Welcome to an inspection of similar articulations in Arabic using Dynamic MRI research paper. This paper will be presented to you by Rahma Tolba, a PhD student at Faculty of Computer and Information Sciences in Shams University, Cairo, Egypt. This paper supervised by Professor Elarif, Professor Zaki Taha, and Dr. Ahmed Tolba. In this presentation, we will start with brief introduction about MRI and Arabic language, the methodology we follow, the results, analysis, and discussion, and finally, conclusion and future work. Let's start with brief introduction. Dynamic MRI refers to continuously acquiring MRI or magnetic resonance images with frame rates sufficient to capture the underlying motion or physiology of interest. Recent advances in dynamic MRI have made it possible to study the anatomy and dynamic motion of the vocal tract during speech production in detail. As a result, researchers will be able to see the structural characteristics of the speakers in conjunction with their articulation dynamics. In addition to that, dynamic MRI has a particular advantage over other techniques such as ultrasound in producing a mid-sagittal view of the entire vocal tract, including the pharyngeal structures, in a safe and non-invasive manner. Understanding human speech production greatly benefits language acquisition, and the Arabic language has novel sounds that are not found in other languages. Arabic novel pronunciation comes out of glottal stops, pharyngalized stops, and fractals. 12 Arabic letters have similar articulation and are very challenging to learn for native and non-native speakers. These 12 letters are divided into 6 groups, with 2 in each group, as shown in the following table. The table displays each letter's group number, name, shape in the Arabic, articulation point description, and IPA. IPA is the International Phonetic Alphabet. It is a widely used system to represent human speech sounds. In our study, we utilized dynamic MRI scanning to investigate 12 Arabic letters anatomy and dynamic motion. It is the first to discuss the details of acquiring dynamic MRI for recording Arabic phonetics pronounced by Arabic phonologists. We developed this dynamic MRI protocol specially for our study, which effectively captured the motion of the target sounds despite being produced from different articulation points. The dynamic MRI scanning was obtained with ethics approval at MRC Mass Radiology Center using Philips Ingenia 1.5 Tesla MRI scanner. The subject head was fixed throughout the scan using D-stream head-neck spine coil combined with flex coverage posterior coil integrated to the table and the base. This coil allows an exceptional SNR or signal-to-noise ratio through digitization in the coil. It also enhances DS-Sense parallel imaging performance, offers flexible positioning, and patient comfort. Then we used ImageJ image processing software to enhance the images and clearly define the vocal tract parts movement. The corresponding image frame of the articulation point was identified for each target letter. This was done by analyzing the MRI video sequences and time-aligned audio. Let's see together 3 groups from our results. Group number 3 that contain letters K and Q. These letters are pronounced from the back of the tongue and upper palate region using the deepest part of the tongue in articulation. The main difference between them is the absence of the pharyngalized feature in the production of Q, as illustrated in the outline contouring figure on the right. This outline contouring figure has been extracted from the MRI images. Group 4 contains letters del and dot. The main difference between them is the shape and position of the tongue. The back of the tongue is raised in dot, forming a cup shape as we see in the middle figure.
أذ أظ
The two letters in this group are both voiced letters. When producing these sounds, the tongue tip is placed between the upper teeth and protrudes out. The primary difference between them is again the shape of the tongue. When making the thal sound, the tongue is relatively flat, and in the back of the tongue is arched and touches the velum. To measure the accuracy of the proposed protocol, we compare the results of S, K, Q, D, T, and the sounds which exist in both Arabic and English with the results of the used protocol in Seeing Speech project from Glasgow University, which was made for English language. As we can notice from the images that our proposed dynamic MRI protocol still offers precise and more detailed results compared to the one used by Glasgow University. Moreover, our proposed protocol shows 70% similarity compared to the one used in the Seeing Speech projects, as shown in the statistics on the right. These statistics are calculated using Image Similarity API, which compares two images and returns a value that tells how visually similar they are. The lower the score, the more contextuality similar the two images are. The high values mean less similarity, which indicates that these sounds are still pronounced differently in Arabic than in English. We can see that the sound is the closest to the English language. K and T are still not close enough to the English pronunciation, where K is having the highest value, which means it differs entirely from how the letter Q is pronounced in English. So we suggest defining a new IPA for the letter Qaf in Arabic from these findings. The result can be used as a reliable anatomical reference to teach the difference between the target sounds. Moreover, it can help understand Arabic phonetics in Turkic and contributes to designing more practical, realistic, and engaging language learning tools for students of all ages through simulating the physical mechanics of speech. While the study of speech production may seem narrow, it has important implication for many areas in linguistics, physiology, and education. The acquired data can be used for several studies in Arabic articulatory phonetics, speech therapy, and vocal tract modeling for Arabic speech synthesis. That's all. Thanks for watching. Feel free to contact me through my email or my LinkedIn account, Rahma Tolba.